countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by eDidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Good evening, teachers, parents, and the students. Welcome to Pusat Tuisyen Academy YouTuber. Bermula percuma, selamanya percuma. How are you doing today? I hope all you are ready for today's lesson. Before we proceed, let's begin our session by reciting a prayer for Muslims. The non-Muslims may pray according to your own religions. Let me introduce myself. I'm Teacher Lau from SMK Tinggi Krang, the moderator of the day. We at Pusat Tuisyen Academy YouTuber will provide you with free online classes. Let's take this opportunity to do your revision. So are you ready? Let me introduce our teacher for today's lesson. We have Cikgu Shahnon from College Matriculasi Pulau Pinang. We are now live on Cikgu Shahnon channel. Please support his channel by clicking subscribe now. The topic of today's lesson is periodic table. So today is the final episode. And together with us, we also have Teacher Kong from College Matriculasi Perak, who is the control host, who in charge ensure the smoothness of our lesson on technical support. And we also have Teacher Tang from College Matriculasi Selangor. She's an observer today to ensure the smoothness of our lesson. So before we begin, I have a few reminders to all of you. First, please pay attention to our lesson. Use the chat box wisely. Second, regarding the certificate link, the link will be given at the end of our session. You can use your MOE or Lima account when you fill in your particulars now. Okay, and make sure to listen to the passcode given by me during the lesson, and fill in the form within the time limit, which is 30 minutes. So first, I will give you the passcode. The first passcode, that is A65. I repeat, A65. So without further ado, let's welcome Cikgu Shahnon.
Assalamualaikum warahmatullahi wabarakatuh, dan salam sejahtera. How are you, students? I hope all of you fine. Okay. Before we start our lesson, of course, I'll try to introduce myself first. This is our poster. All right. Every Sunday, we will live at 3:30 p.m. And this is my profile. My name is Shahnon bin Awi from College Matriculasi Pulau Pinang, and my teaching experience 21 years, and my channel is Shahnon channel, www.youtube.com/Shahnon channel. Okay, and this is our Kimia Prayu members. We have Teacher Vivi Lau as our moderator today, and Teacher Tang as observer, Cikgu Mawar and Teacher Kong as technical part or host controller, and this is me. And this is our teammate mathematics also has a video collection, STPM and matriculation, and lead by teacher Im. Okay, and this is biology AYU, led by Cikgu Faiza. Accountant and economy AYU, led by Madam Fizi. And the last one is physics STPM AYU, led by Madam Rosmaya. And don't forget, this is our portal, Academy YouTuber Malaysia. I think you should visit this portal because a lot of information. We have a tutorial, we have a live videos here, and so on. So many things in Academy YouTuber Malaysia. Bermula percuma, selamanya percuma. Okay. Now we go to our main topic today. Our main topic today is periodic table, the last episode. Okay, the last episode, and the subtopic, as I can say, subtopic electronegativity. Okay, and for this session, I'll try to explain the variation in electronegativity of elements, and then explain the metallic character, explain melting and boiling point of element in period 3, and explain the acid-base character of oxide of elements in period 3. Okay, we go to the first one, which is electronegativity. Okay, this is definition of electronegativity. Electronegativity is the relative tendency of an atom to attract bonding electron to itself in covalent bond. For example, we have example here, HCl, for example. This is bonding bond between hydrogen and chlorine. Okay, this is bonding bond between hydrogen and chlorine. And then chlorine here, chlorine now attract this bonding electron more to chlorine. That's why, as we can see here, chlorine here we give partially negative, okay? Partially negative, and hydrogen partially positive. That means in this case, chlorine, the relative tendency of chlorine to attract bonding electron to itself is more compared to hydrogen. Okay. Okay, and if we cross a period, we can see that electronegativity increases across a period. And then when we down a group, we can see that electronegativity is decreased. And because of that, we can see that the factor that affecting of electronegativity are atomic size and effective nuclear charge. Because when we cross a period, the atomic size of element becomes smaller and effective nuclear charge of element become stronger. Okay, this is one of the factor. And also ionization energy. All right, ionization energy, because when we cross a period, we also know that the ionization energy of element increase, and more exothermic electron affinity and highly electronegative atom. Okay, because of this factor, we can have a, when we cross a period and we down a group, we can have this we can put this side by side, so easy for us to differentiate. Okay, now we look at cross a period. Okay, when we cross a period, okay, I make it bigger so easy for us to see. The proton number increases. Okay, cross a period, the proton number increases, and we know that the atomic size decreases because effective nuclear charge also increases. Because of that, the force of attraction of nucleus towards bonding electron increases, and thus electronegativity increases. That's why when we cross a period, electronegativity increases. Okay, now we look at down a group, what happens if we down a group? We already know that the principal quantum number of n, the principal quantum number n increases when we down a group, or the number of shell increases. Okay, down a group from period 1, period 2, period 3, period 4, and so on. Okay, the principal quantum number increases, and the atomic size also increases. Because of that, the shielding effect also increases. Because the shielding effect increases, the force of attraction of nucleus towards bonding electron decreases. That's why when we have a atom that has a bigger in size, the electronegativity must be less. All right. So from here, okay, let's say I want to show you this one. Okay, this is predictable. Okay, this is predictable. As I mentioned, let's say I want to cross period 2. Okay, beryllium. This is beryllium, and the electronegativity is I will show you the electronegativity here. Electronegativity. Where is electronegativity? Yeah. This is the value of electronegativity. 1.75. 1.75 here. This is the electronegativity of beryllium. Now I want to cross a period. That's mean, let's say boron. Okay, boron. Okay, look at boron. What the value of electronegativity of boron? Okay, put it here. 2.04. Okay, 2.04. Okay, after boron is carbon. Okay, let's say carbon. 2.55. Okay, can we see increase in electronegativity? And fluorine actually is the highest in electronegativity in predictable. Okay, fluorine has the highest electronegativity, 3.98. This is the value of electronegativity of fluorine. And for neon, then this is neon, Na. What is Na? Not available. Okay, not available because this is group 18. Okay, this group 18 is not active. Okay. So from left to right, from lithium, beryllium, carbon, boron, carbon, nitrogen, and so on, we can see that electronegativity increase. Okay, now down the group. Okay, I'll take period 2. Okay, beryllium. Beryllium is 1.75. Okay, we expect that electronegativity will decrease. Okay, magnesium. Look at magnesium, 1.31. Okay, strontium, 0.95. Okay, can we see? The trend is when we down a group, the electronegativity will decrease, and cross a period, and the electronegativity will increase. Okay, the question is, what happens if I have beryllium? Okay, let me. Oh, okay. Okay, this is beryllium. And I try to compare with bromine. All right. Okay, I try to compare the electronegativity of beryllium and bromine. Okay. In this case, bromine at our right hand side, that's mean higher electronegativity. Okay, higher electronegativity because at our right hand side. But in case of we refer to the principal quantum number. Okay, this is principal quantum number. Beryllium at shell number 2. Okay, shell number 2. This is number 2. And for bromine, shell number 4. That means the principal, the electronegativity when we down a group should be less. Okay, but bromine at our right hand side increase. So in this case, which one is more negative? beryllium or bromine? Okay, student. Student, you can try answer this question. Okay, student, can you answer this question? Which one is more electronegative, beryllium or bromine? Okay, beryllium or bromine, because we have two parameters that change the electronegativity. Okay, when we cross a period, the electronegativity will increase, but when we down a group, the electronegativity will decrease. But in this case, we have two parameters changing at the same time. So this is just to know whether which one actually more dominant, cross a period or down a group. Okay, any answer from student? Student, you can try. You can try answer this easy question. Easy question. Huh? Which one? I already mark beryllium and bromine here. You can choose which one is more electronegative. Electronegative, whether beryllium or boron. Beryllium or bromine? Boron. Beryllium or bromine? Anyone want to answer this question? Very easy. And we have a value here. We can show it here. I think very small, but I can read it for you. Anyone to answer this? No one. Okay. Okay. Let me show you the answer. Okay. Okay. I think no one want to answer. Okay. Beryllium. Okay. This is the value of beryllium 1.75, and for bromine 2.9, 2.96. That's mean bromine has higher electronegativity than beryllium, even though the principal quantum number of bromine higher than beryllium. Okay, maybe this is because of when we cross a period, the size of bromine, even though the size of bromine bigger than beryllium, but maybe because of effective nuclear charge and proton number and so on, and because of that, the electronegativity of bromine higher than beryllium. Okay, all right, and then we proceed to, let me wrap this one first. We'll go to the next. Okay. Okay, now finish electronegativity. Now we go to the metallic character. Metallic character. As we can see here, this is predictable. We have three color here. Okay. The first one is the color is quite white. Okay, white in color, and then we have a red and the blue one here. Blue one. And then the white one here, as we can see, is a metal, except for hydrogen. Okay, except for hydrogen. Hydrogen not a metal, and this is metal. And we have a red one. The red one, they call it a metalloid. Metalloid. Okay, this is metalloid. And for the blue, I think blue. Okay, the blue one is non-metal. Okay, so from here it is clear that when we cross a period, this is from metal to metalloid and non-metal. So cross a period, metallic character decreases. All right, and down a group, the metallic character metallic character increases. Usually, when we cross and down the group, the characteristic will opposite. Okay, cross increase, down decrease. Cross decrease, down increase. Usually, the properties of in periodic table like that. Okay, whether it is size, i.e., effective nuclear charge, and so on. Usually, we will see this kind of properties. Okay, increase, decrease. Okay, if it is increased, this one will decrease. Okay, so okay, we take period 3, for example. Okay, we take period 3. Period 3. We have a sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. Okay, this is period 3. Cross a period, as I mentioned, cross a period. We already know that the atomic radii will decrease. Okay, this is cross a period. And if cross a period, atomic radii decrease, of course, down a group, atomic radii will increase. We will have this kind of opposite characteristic. Okay, IE. Okay, look at IE here. Cross a period, IE increases. That's mean when we down a group, IE will decrease. Okay, we will see this one. All right, and sodium, magnesium, aluminum are metal. Okay, silicon, metalloid, and this one is non-metal. Okay, metallic character decreases across a period. Okay, because this is metal and this is non-metal. Of course, cross a period, metallic character decreases cross a period. And then increases down a group. If you down a group, the metallic character is increased. Okay, what is metallic characters? And before we go to what is metallic character is closely related to atomic radius. Okay, that's why we have a atomic radius here, or atomic radii, and IE, ionization energy. Okay, we have this one. Atomic radius or atomic size increases, metallic character increases. Okay, atomic radius, this one, down a group. And ionization energy, and ionization energy decreases. That's mean easier to remove electron from atom, and that's mean metallic character increases. That's mean actually the definition of metallic character is the easier to remove electron from an element. That is definition of metallic character. Okay, metallic character means the ease of removing of electron from an element. That is definition of metallic character. Okay, that's mean less energy is needed. That's mean IE is less. That's mean when we refer to the removing of electron, that's mean we will refer also to the ionic radius, because if the ionic radius is smaller, for example, not easy to remove electron because attraction of nucleus towards valence electron stronger, right? So we have this kind of relationship. Okay, metallic character, size, IE, and so on. Okay, all of them interrelated. Okay, all right, and then straight go to this one. And okay, this is very important. Don't confuse between metallic character and metallic bond. This one is actually the different, a lot of difference between metallic bond, metallic character, and the structure of metallic. Okay, this is different. Okay, let me see the period 3 element. Okay, metallic, the melting point, the melting and boiling point of period 3, for example. Okay, this is sodium, magnesium, and aluminium. Okay, the melting point is 98. Okay, melting point for magnesium and 650, and so on. Okay, from here we can see that metallic bond, melting point and boiling point increases when from sodium to aluminium. Okay, before that we have to characterize these into three, okay, into three parts, because sodium, magnesium, and aluminum are metal, so they are in group of metal. And for silicon is in a different type of what we call giant covalent structure. So silicon in different part, and we have what we call simple molecule for phosphorus, sulfur, chlorine, and argon. Okay, so we have to divide it, them in structure. This is structure of sodium, magnesium, aluminum. In structure of, we call it metallic, and for silicon, giant covalent structure, and for phosphorus, sulfur, chlorine, and argon as a simple molecule. Okay, this is their structure. And the second one is type of bonding, okay, or intermolecular force. For sodium, magnesium, and aluminum, type of bonding, we call it metallic bond. And for silicon, covalent bond. And for phosphorus, silicon, chlorine, and argon, van der Waals forces, right? So we have to differentiate them into three parts first before we can discuss their melting point and boiling point. Okay, because the melting point of a substance depend on the strength of bond. Okay, the strength of bond. Metallic bond, usually metallic bond are stronger than van der Waals forces. Okay, and then the type of intermolecular force, this one lah, van der Waals forces, they have double forces, hydrogen bonding, and so on. Okay, and structure. Okay, and this is structure, whether it is metallic, giant covalent bond, or simple molecule. Okay, as I said, we have to differentiate between metallic bond and metallic character. Metallic character means the ease of removing of electron from element. Okay, and for metallic bond is electrostatic force, okay, between the positively charged and its um, what we call electrostatic force between positive charge and its valence electron. Okay, different things. All right, so this is the how we try to let me zoom first. Okay, this one. Okay, why sodium? The melting point and boiling point of sodium less than magnesium and less than aluminum. All right, this is because of metallic bond, the strength of metallic bond. In this case, actually, the strength of metallic bond of aluminum stronger than magnesium and sodium because of charge of positive ion is higher. Okay, we know that the charge for aluminum is 3 plus, the charge for magnesium is 2 plus, and sodium is plus, right? Okay, and then the number of valence electron, of aluminum 3, magnesium is 2, sodium is 1. Okay, here we have here. Okay, here. Okay, the charge, and also the number of valence electron. Okay, the higher the number of valence electron, the stronger the electron, the stronger the metallic bond. Because of that, sodium. Okay, sodium. All right, sodium. The melting point of sodium less than magnesium and less than aluminum. Okay, this is one of the factor. The second one is the size. Actually, is the size. And across the period, sodium, magnesium, aluminum, the size of aluminum is smaller than magnesium. Okay, because of that, the melting point and the boiling point of aluminum higher than magnesium and sodium. Okay, all right. This is when we try to explain the metallic bond in from sodium to aluminum. Okay, this is silicon. Oh no, okay. So let me show you the. Okay, this is the structure of metallic bond. We have a positively charged here. This is positively charged. For example, we have sodium, so here should be Na plus, and so on. And this is the valence. We call it mobile valence electron or delocalized valence electron of sodium. Okay, attract electrostatic force between the positively charged and its valence electron. We call it a metallic bond. Okay, this is in
Sorry, Cikgu
yeah.
Shahnon, can we rest for the
Okay,
advertisement?
no problem. Okay, we rest for a while.
Thank you.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Thank you, Shahnon. You can continue. Thank you.
Okay, welcome back. Okay, now we go to the silicon. Okay, let me zoom it. Zoom in. Okay. Silicon, in case of silicon has a giant covalent structure with each atom strongly held by a strong covalent bond. That's why we see that silicon has the highest in boiling and melting point, okay, compared to aluminium, sodium, and magnesium. Okay. Each silicon atom is tetrahedrally bonded to 4 other silicon atoms to form gigantic covalent network, and more heat energy is needed to break the strong covalent bond in melting or boiling. Okay, let me see the structure. This is the structure of silicon. All right. Okay, let me zoom in. Okay, let's say this is silicon, and this is another silicon atom, and here we have a covalent bond here, covalent bond between atoms of silicon, and more energy is needed to break this covalent because the covalent bond, the covalent quite strong, not easy to break the bond of covalent bond. Need more energy. That's why, and the structure is a giant, gigantic covalent structure. More energy is needed to break the covalent bond between silicon atoms. That's why it has higher melting and boiling point. Okay, and then okay, this is silicon, and then look at the argon, chlorine, phosphorus, and sulfur. For phosphorus, sulfur, and chlorine in what we call in a normal condition, it exists as P4. Okay, phosphorus will combine with 4 other phosphorus to form P4. For sulfur will combine and it's become molecule as 8. And for chlorine, it's tend to form Dewey atom. Okay, chlorine tends to combine and form Dewey atom, and argon mono atom. Okay, argon tends to form at normal condition as a monoatom. Okay, because of that, this molecule have we call it simple, okay, simple covalent structure, not very big compared to silicon, giant, okay, a lot of atom. Okay, but for this, just a simple covalent molecule structure. We have a 1, we have a 2, we have a 4 and 8, just a simple. and are held by weak intermolecular forces. We call it van der Waals forces. Okay, the structure is uh, held by a only weak van der Waals forces. And the van der Waals forces is proportional to the molecular size. In case of van der Waals forces, it depends on molecular size. The higher the molecular size, the stronger the intermolecular force. Okay, because of that, we can see that S8 sulfur with 8 atoms combined together, of course, the molecular size bigger than P, because P only 4. Okay? Only 4 atoms that combine together, and chlorine only 2. Only 2. And argon is mono, only 1. Because of that, we know that the larger the molecular size, the stronger the van der Waals forces, and melting point and boiling point higher. Okay. And then look at this one. I think I don't have to zoom in. We just look at this. What is van der Waals forces? This is the van der Waals forces. This one. This one is van der Waals forces. Actually, this is water molecule. Okay, this is water molecule, and this is the intermolecular force between water molecule. This one. Okay. This one is intermolecular force between. This intermolecular force, the strength is not higher enough compared to covalent bond as in silicon. Okay? Not strong enough. So less energy is needed to break this bond. That's why the melting point and the boiling point of simple covalent structure less than silicon and also metallic bond. Metallic bond also actually giant covalent structure also for metallic bond, as we can see the model before that. Okay. Oops, what happened? I lost my, okay, no problem. I lost my PowerPoint, and I will show it again. Okay. Okay, sorry for that. My PowerPoint not stable, I think. Okay. Okay. Hopefully, I can show you my PowerPoint again. This one. Oh, yeah. Oh, sorry. Until this one, I think. This one. Okay. Let's go. Yeah. Okay. This one. Okay. Let me. Okay. Can you see? Let me see. Can see, yeah? Hello? Okay. I think everybody can see, yeah?
Can
Okay,
see.
good. Where is it? Okay, until here. So, okay. Let me see. Okay. This is the structure of metal, and this is giant covalent structure. And okay, this is van der Waals forces. Okay. And I also have this one. Okay, this what we call this is chlorine and bromine. We can see the fluorine here. The molecular size is smaller than chlorine. Okay, smaller than chlorine, and because of that, we can see that the strength of intermolecular force of chlorine, of course, higher compared to fluorine, because fluorine has a smaller in molecular size. Okay, chlorine higher in molecular size. Okay. 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 Now, if we want to discuss about melting and boiling point of element down a group, okay, we have to very careful, because if we choose group 1 and we choose group 70, we can see the different things. Okay, down a group, we can see that the decrease in boiling point and boiling point. But for group 17, increase in melting point and boiling point. And why? Okay, why this thing happen? Because of type of bond. Okay, for group 1, we increase because metallic bond. Okay, actually we refer to the elements, and the type of bonding is metallic bond. But for group 17, this one, the type of bonding is van der Waals forces. Okay, van der Waals forces. This is the different thing. As we can see that for metallic bond, the higher the ionic radius, the higher the ionic radius, the strength of metallic bond become reduced or decrease, right? That's why, okay, here we have a lithium. Here we have a lithium. Let's say we take boiling point 1340, the melting point. But for cesium, because the size of cesium larger, and shielding effect bigger, and so on, so the attraction of nucleus toward the, because for group 1, the charge is positive one. All of them are positive, but the factor that affect the metallic bond is size. Okay, the higher the size means the lower the strength of metallic bond. Okay, that's why decrease when we down the group 1. Okay, if you look at group 17, we can see the opposite effect. Okay, down the group, fluorine boiling point in negative 188, but for iodine, and if you look at the phase, for fluorine is gas, chlorine is gas. This is in a standard condition. Standard condition means temperature 25 degrees Celsius, and the pressure is 180 m. Okay, the phase of bromine is liquid. The phase of iodine is solid. We can see from here, and of course, the boiling point of iodine higher, 184.4 degrees Celsius compared to bromine 59, and chlorine negative 103. Because of what? The atomic radii increases. Okay, when we down a group, of course, the atomic radii will increase, but because of type of bonding, we can see that for group 17, down a group, the boiling point higher, become higher and higher for boiling point and melting point. But for for metal, for group 2, decreases. Okay. Okay, let me. I have to rub this one. Okay, and then okay, this one. Okay, this is what I said for fluorine here, because of the size of fluorine and chlorine. Actually, because the size relate to the intermolecular force. Intermolecular force relate to the size. The bigger the molecular weight means bigger molecular size, and higher what we call what I'm still remember the words, the terms. Okay, the higher the molecular size means higher contact surface area. Yes, contact surface area between chlorine. Okay, because of that, the strength of intermolecular force. In this case, intermolecular force is van der Waals forces, bigger. Okay. Okay. And now we go to the last of this last episode. Okay. Acid-base character of oxide of period 3 element. We still refer to the period 3 element. Okay. Easy for us to discuss. Just period 3. Yeah. We don't discuss period 4, or not easy to discuss. Okay. From period 3, metal form. This is a basic knowledge. I think basic knowledge. Metal will form basic oxide. All right. Non-metal will form acidic oxide. This is a basic knowledge. Basicity here is basicity cross a period become acidity. All right. Say period 3. Sodium, when it's combined with oxygen, it will become oxide of sodium, Na2O. Magnesium, oxide of magnesium is magnesium oxide, MgO. Okay, I think you already know that because Na plus and O2 minus combined together, so it's become Na2O. Mg2 plus, O2 minus combined together, and it's become MgO. Okay, and aluminum, Al3 plus and O2 minus combined, it's become Al2O3. Okay, I think this is no problem. But in this case, for sodium oxide and magnesium oxide, actually the acid-base nature is basic. And for aluminum oxide and for tertiary, and for the non-metal oxide, silicon, phosphorus, sulfur, and chlorine, the acid-base nature are acidic. Okay. Okay. We have a basic, amphoteric, and acidic. Okay. What is amphoteric? Okay. All right. Okay. Look at here. Okay. This is oxide of magnesium, and oxide of sodium. Both can react with water to form magnesium hydroxide and sodium hydroxide. And we already know that magnesium oxide and sodium oxide are basic, right? So oxide of magnesium react with water and form base. Okay, and to show that oxide of metal, sodium oxide and magnesium oxide are basic when they can react with acid to form salt and water. Okay. Na2O solid here can react with HCl. HCl is acid. Okay, and form salt and water. This is show that oxide of sodium or sodium oxide is basic because it can react with acid. Oxide of sodium is basic because it can react with acid. Same goes to magnesium oxide. Magnesium oxide can react with acid to form salt and water. Okay, this is how we try to explain the basicity of the basic concept. No, the basic properties of metal oxide, right? For aluminum oxide, okay, in case of aluminum oxide, it is insoluble in water, okay, insoluble, and aluminum oxide can react with acid. HCl is acid. Aluminum oxide can react with acid. That means aluminum oxide is basic because it can react with acid to form salt and water. And the best thing about aluminum oxide also can react with base, NaOH. NaOH is base. Alright? That means aluminum oxide, in this case, in this reaction, aluminum oxide is an acid. Okay? An acid. Acid, because acid can react with base. But in this case, aluminum oxide is a base because it react with acid. That's why we call it aluminum oxide is amphoteric. Okay, amphoteric. It can be an acid or it can be a base. Depends on condition. Okay, depend on condition. Right. Okay, this is amphoteric. Some sort like amphibia. Amphibia lah. Amphibia, kodok, katak, and so on. Yeah. And this one is acidic oxide. For P4 or 6, P4 or 10, this is oxide of non-metal, phosphorus. Okay, react with water and form this one. All of these are acid. H3PO4, H3PO3, and H2SO3, and so on. All of these are acid, right? That means that all non-metal oxide can react with water and form acid. And okay, we take SiO2 here. SiO2 here is oxide of silicon. It can react with base, NaOH. Okay, it can react with base and form salt and water. So this is the proof that oxide of non-metal acidic oxide. Okay, I think that's all for today. Our last episode of periodic table. Thank you. Please subscribe, like, and share Shahnon channel. Okay, go back to our moderator.
Sorry, unmute. Forgot to unmute myself. Okay, thank you, Cikgu Shahnon. With God's grace, we are done with today's session. We have learned a lot from Cikgu Shahnon about periodic table. Congratulations to those who are able to follow our session from the beginning till the end. And thank you very much, Cikgu Shahnon, for such an interesting lesson. Before I provide the certificate link, please check the chat box for the certificate link. Please off the live chat button and click subscribe button if you haven't. This is to show your appreciation to Cikgu Shahnon for giving you a free lesson today. Don't forget to click the bell button too, so you won't miss out any new videos and live classes from Cikgu Shahnon. If you like today's class, then please click like and share it to your social media friends. Let's share the knowledge you received today with them. Sharing is caring, right? So the last code for the today online class is 99. Last passcode. Okay. So once again, I would like to thank you, Cikgu Shahnon, for the interesting lesson. Thank you also to Teacher Kong and Teacher Tang for being with us today. I think that's all for now. See you in another session. Please do remember, stay at home. Goodbye, everyone. Have a nice weekend.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau.
Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.